Hi, welcome to today's session on geometric sequences. So a geometric sequence, some of you may know it as geometric progression. They are similar to linear sequences and similar to quadratic sequences, but they have a difference. With linear sequences and quadratic sequences, those are working on the basis of what we call arithmetic sequences. So you are constantly looking at additions, subtractions, multiplications, divisions. With with geometric sequences, we are looking at common ratios. So we are predominantly going to be looking at how do we get from one number to the next using a ratio. So here we've got 2, 4, 8, 16, 32, where our position of these terms 1, 2, 3, 4, and 5. I've done number 2, the first term, in a slightly different colour, which will become more apparent in just one moment. But as you can see, to get from one number to the next, some of you may have already spotted it, each of the numbers are doubling each time to give us the next number in the sequence. So it's multiplying by 2. This is a constant multiplication, but this is also a common ratio. So in general, we could write a geometric sequence as A, AR squared, AR to the power of 3, and so forth. If we was to look at this sequence, A is our first term, which is number 2, and then R is our multiplication. So here we've got A, which is 2, so our first term is 2. 2 times 2, which gives us 4. 2 times 2 to the power of 2 gives me 8, and carrying on as we go up. So the general rule for geometric sequence is x of n equals AR to the power of n minus 1. So here I've got my sequence that we saw before, and 2, 4, 8, 16, and 32. And as we saw before, it's multiplying by 2 each time. So we could be asked to find out what generate a sequence for this rule, where A equals 2. So our A will be substituted in for 2, and R equals 2. So if we was to find our first term, so finding our x value of our first term equals 2 times 2 to the power of 1 minus 1. Now, that 1 just inside here, that is because we are looking for our first term. So 1 minus 1 is 0, anything to the power of 0 is 1, so 2 times 1, that gives me 2. And 2 is my first term of this sequence. For the second term, that gives me 4. Third term, that gives me 8. Fourth term, that gives me 16. And my fifth term, that certainly does give me 32. So my end conclusion is that my sequence generated from this rule, where A equals 2, R equals 2, is 2, 4, 8, 16, 32, and then carrying on. And we know this is right because this is exactly what was working with in the first instance. If you like what you see, please subscribe. Thank you very much for watching.